Hello and welcome to today's MDDI QMed webinar, 5 Ways to Prevent Packaging Failures, sponsored by Oliver Healthcare Packaging and broadcast by Informa. I'm Daphne Allen, editor of MDDI, and I'll be your moderator today. We have just a few announcements before we begin. This webinar is designed to be interactive. The dock of widgets at the bottom of your screen will allow you to learn about today's speakers, download resources, share this webinar via social media outlets, and participate in the Q&A session that takes place at the end of our presentation. The slides will advance automatically throughout the event. You may also download a copy of the slides via the resources widget. Toward the end of our webinar, we will ask you to complete our survey found on the right-hand side of your screen. Please take a minute to fill this out before leaving us today, as your feedback will provide us with valuable information on how we can improve future events. Lastly, if you're experiencing any technical problems, please click the Help widget found at the bottom of your screen, or type your issue into the Q&A area, and we will be glad to offer one-on-one assistance. Now, on to the presentation, 5 Ways to Prevent Packaging Failures. Discussing today's topic are Kevin Fisher, Technical Manager at Oliver Healthcare Packaging, and Jen Goff, Global Director, Product Strategy at Oliver Healthcare Packaging. To learn more about our speakers, please stay on screen and visit the Bios widget. Jen, Kevin, over to you.
Thank you, Daphne. Today's title is 5 Ways to Prevent Packaging Failures, and some of the topics we'll be touching on are Know Your Device and How It's Used, Design for Success, Don't Overlook the Shipping Configuration, Identify Failure Modes Early and Often, and my favorite, Build Trust with Your Operators. So we always like to state the problem. Due to rigorous and lengthy medical device packaging requirements, the upfront planning, device knowledge, and design will make or break a first-time pass. Our goal here is don't be the problem.
Yeah, Kevin, and with the right opportunity, not only will the packaging requirements not be the problem, but it can also add value to the overall product by creating a competitive advantage and insist in the efficacy of the procedure. So our first way to prevent packaging failures is knowing your device and how it is used. So Kevin, can you walk us through the materials and the importance of knowing the materials of your device?
Yeah, so we always encourage our customers or engineers to provide a final product or as close as possible, because different substrates or the outside the device's materials come into play when you're trying to design. So example would be in the pictures here on the top left, you have brushed metal might react differently than a slick metal. A plastic with a radius edge might have to design differently than a plastic with a rough edge. On the bottom left, just tubing, simple tubing. It can have a tacky, sticky surface, so you don't have to grip it as much, or it could be hard and slick. So definitely knowing the device and getting a final device before doing your testing is key.
Yeah, and as I look at the bottom middle picture, I see electrical components in the device as well. And it's really important, if you have any sort of electrical components, to ensure you're working with your quality team, your electrical safety team, to ensure that any requirements per IEC 60601 are fulfilled. There may be some additional requirements. So if you have any electrical components in your device, make sure that you are connecting with the appropriate resources to cover your bases.
Yeah, that's a good point. Anytime our design crew sees exposed electrodes and it wasn't discussed in the previous conversation, we do a full stop, and we definitely have a deeper conversation from that point.
Absolutely. So the next piece, an important piece about knowing your device, is device fragility. So Kevin, can you walk us through device fragility and the importance of knowing that about your device?
Yeah, you definitely need to isolate what's robust and what is fragile. I mean, no one knows the product better than the engineers who worked on it, so having that lengthy discussion up front, combined with our experience or designers' experience who know packaging, I think a good first go or a solid design can be designed right off the bat. But there are hidden, through experience, there are hidden dangers. There are sometimes fragility pops up where you don't expect it. So if you go to the next, that slide on the left side there, you see a lure that goes into the handle. It's actually a case study where we came up with a typical design. It should have worked, but that part had a weak joint to it, weaker than typical. And so we just did a pivot, and that's what happens. You do your feasibility testing up front, you find out things about your device, you make a small design change, you add cushion in this case where on impact it softens the blow, and you're good to go.
Yeah, absolutely. I mean, as packaging engineers, we're constantly thinking about the sterile barrier and making sure that there's no microbial ingress. But an equally important part of the packaging design is to protect the device as well. So, and another thing too, as you're working through these types of devices, your manufacturing engineers will know and have risk analysis on potential weak points of the device. So partnering with your manufacturing engineers and having them help you understand a little bit more about any potential risks of fragility in the device is also helpful. So Kevin, can you talk to us a bit about the importance of coatings and knowing the coatings on devices?
Yeah, so coatings are clear. They're quite often, they come on a lot of devices that we design for, and they're part of the device. So just like the device itself, it has to get to the end user intact. So you need to design accordingly. You ask your questions up front, see how sensitive of a coating it is and what it can take, and you design the appropriate design from that point.
Yeah, have you ever had a situation, Kevin, in your experience where you've seen, flaking of the coating or denting or abrasions of the coating that's created a failure during design and development?
Yes, on occasion. So it's typically when a customer doesn't want to add a tube. A tube, historically, a device goes into a tube that's incorporated into the card or the packaging system, and it protects it really, really well. But when a customer doesn't want to add that part number or that cost to their package, they might try first a flat edge of the card to hold down the shaft or the device with the coating, and that's a great idea. You want to make sure you get your packaging in the budget, but there have been reports coming back to us that it didn't work, it scraped a little bit, and then we just, again, pivot and go to a tube from there.
Excellent. Yeah, so Kevin kind of just walked us through some very important things to understand about your device. Obviously, there are the basics around, shape, geometry, weight, and such. But these three things are definitely important to understand so that when you are creating your user needs and design inputs, really, you're able to design the appropriate device or the appropriate package. So now we're going to move more into how the product is used. So it's important to know the device. And its components, how it's manufactured, all of those fun things. And it's also equally important to know how it's used. Because of the requirements in ISO 11607 for usability studies, it's important to understand upfront how the device and the packaging are going to be used with the end user. And so really the packaging has to be able to be effectively, intuitively, and efficiently transferred into the sterile field. And so ensuring that you know how that is happening and who is doing it and where it's being done are important aspects of understanding how it's used. Another aspect is understanding where the product is going to be stored. Is it going to be stored in an OR or in a cath lab or in a storage closet? This will allow you to really help create any sort of graphics or labeling with the product that can help the end user access the device as quick and efficiently as possible. Another one is, is there an order in which the components are being used in a procedure? So some devices have multiple components within the packaging. And so it's important to understand at what points those are going to be used in the procedure, or it is also important to understand, do any of those components need to be assembled prior to use in the procedure? Your packaging can help facilitate an intuitive experience for your end user if any of that, assembly or sequential order needs to happen. And then lastly, understanding how and where the product is going to be disposed is really going to help you understand what type of materials you should be selecting and be considering when you understand where and how the product is going to be disposed. So number one, we talked about knowing your product and knowing your device. The second way in which to prevent packaging failures is really designing for, oh, you know what, I got ahead of myself, so I'm going to start back at this one. So actually, when you talk about your device, understanding your device and understanding how the product is used, you also want to consider the user needs and design inputs. So packaging owns the user needs and the design inputs for the packaging, of course. So what that means, you know, oftentimes design inputs can be very similar from device to device, but it's our responsibility to know what they are, why they are, and where they came from. So this helps you prevent any unexpected failures or misses in testing. So, you know, thinking about what is a failure. So if a device dislodges from the packaging, but there's no sterile breach, and the device still works, is this considered a failure? Those are the types of things you want to think through when creating your design inputs for your packaging. If you look here, we have a checklist that walks through, it's not all encompassing, but it's pretty close to all of the questions you might want to ask yourself so that you can feel empowered to be part of the design input process. Many times, like I'd mentioned, the inputs are similar from device to device. So what I've seen is whoever owns that document may be doing a cut and paste of a predicate device or a different device with a sterile barrier, and it's a cut and paste that they put into their design inputs. So if that is the case, you want to really make sure that that is correct for the package and the device, the product that you are designing for. So now going back, we went through, we talked about the device and understanding the device and understanding how it's used. So the anticipation of number two, what is it? It is designing for success. So we want to design for success. And really, you know, Kevin, as we are designing for success, what is the most important thing that people really need to understand that they sometimes don't?
Do not underestimate the severity of testing. So testing is not easy, and it's a little bit surprising. Some customers come in or engineers come in who are not packaging engineers and they have to wear that packaging hat. And they're a little bit shocked. They're usually focused on the end user and its performance, but if you don't pass your testing, you can't get to the end user. So many just don't understand the rigorous testing coming up that they'll be facing.
Absolutely. So we have a video just here for those of you who may have not seen the different conditioning that happens in a packaging or in packages when it goes through a distribution cycle. This is a drop test. This is one of, I think, 12 drop tests that happen a couple feet above the earth. And, you know, this is showing that this one test, this one drop created basically a dart that went through the sterile barrier. So it's just really important to understand that the device or the package that you're designing and the device interaction with the packaging is going to go through some very rigorous testing. This is one example, but there's, you know, vibration, there's compression, there are a lot of different tests that these packages go through to ensure that when they get to the end user after shipping, it still maintains a sterile barrier. So next, we're going to talk about the different packaging types. So we're going to talk probably high level, a few things that you need to consider, you know, that you can probably go in depth on other webinars that we've had out there with regard to packaging types, material types. And then we're going to get a little bit into some specific design features. And the design features we're going to talk about are really more in the card space, because that is what we do, and that's where our experience lies. So while some of the advice and considerations that Kevin will share with you are very specific to cards, there are also things that you can think about when you're working on trays or other packaging platforms. So the first thing we're going to talk about are package types. So whether it's a pouch or a tray, a card, there are plenty of package types to consider. And I think what's most important is really knowing what the end user needs, but also understanding why. What does R&D need and why? And what does manufacturing need and why? It's really important to probe deeper into the answers to some of the questions of what are you looking for? You know, doing some of that research up front is going to allow you to collect the information that you need so that you can feel empowered to create the appropriate design inputs and choose the correct packaging to ensure you not only pass the first time, but also you also prevent issues with customers, operations, or next-gen devices down the road. The second piece to consider is material selection. So I was really surprised, I would say, coming to Oliver from a couple of medical device companies in my recent history, to find out that there are hundreds of material types. Now, of course, being a packaging engineer, I knew that there were hundreds of material types, but when it comes to medical packaging, I really only had familiarity and success with a couple. So I was really shocked to find out that there was probably opportunity in my history to really optimize the design and solve for problems ahead of potential, failing. I definitely don't have a perfect streak. I have had packages that have failed in my past. So had I had some of this knowledge to understand a little bit more about the failure modes and how these materials can really solve the problem from these, solve these failure modes, I could have been more successful in my past. So if you look at different films, different foils, coated versus uncoated, all of these different opportunities, or these are all opportunities to potentially solve for a problem with your specific design and configuration. And then also considering pouch features. So this is more in the usability range, but if you think about pouch features, there are a lot of different things that you can consider. These are only a few, but a few that I thought were quite common, and also things that really solve for problems that we may not consider always. So thinking about a thumb notch that creates an intuitive guide to end users, or a hang hole which allows you to store devices upright to prevent damage, or even to save space depending on where it's stored, or a care notch or a slit, which is usually used for weld-sealed pouches. That type of feature specifically, we're used to seeing that in our everyday lives, right? So if you open a Tylenol foil pouch, you're typically going to see a slit there. And that is just an intuitive design feature that helps our end users understand that they can tear that open instead of having to go grab some scissors. So, Kevin, I would like you to talk a little bit more about some design features specifically in the card realm. Can you walk us through a coiled versus straight design and some considerations you might have when designing your packaging?
Yeah, I think that's a huge question on an initial call when you're talking about designing packaging. One of the first questions we ask is, can it be coiled or does it have to be straight? If you can have it coiled, then you are facing less costs, less waste, enhanced usability, meaning it's smaller, more compact, so it's easier to handle, especially during the septic transfer. And then it takes up less space in the closet. Anytime you take up less space, you are more competitive than, say, if there's a competitive device out there, it has a larger footprint. So there's a lot of benefits to being able to coil a design and not have it in a long, straight fashion. So I guess the biggest thing here is, can it do it? Will it take a set after sterilization and make the device non-functional or not as functional sometimes? That's a gray area that you have to consider. So yeah, definitely one of the questions we ask is, can it coil? And it pays to, before talking to your packaging house or design house, do some tests initially to see what the overall ID can be if it can indeed be coiled.
Absolutely. So the flip side of that is a straight device. Kevin, talk us through a little bit about the considerations for a straight device.
Yeah, the benefits are a little more limited, but you definitely have no kinking, but it comes at a price where it's higher cost. There is more waste to it, and anytime you ship anything around the world that's oversized, there could be increased shipping costs as well.
Yeah, so, when I look at those two photos from the straight to the coiled, help me understand why it's more of a cost for a straight design than a coiled. It seems as though there's pretty similar amount of material, but I could be wrong.
Yeah, it's just the photo. I mean, the coil is typically around 10 by 12 inches overall packaging versus possibly a 6-foot long card. So it is material, but it's not the main driver. Really, just like the box world, as you get past a certain size or certain length, you might go to a larger, more costly, possibly slower machine. So you might go from an automated machine down to up to a semi-automatic machine. So that all plays a role when determining costs on these.
That makes a ton of sense. Thank you, Kevin. What about preventing seal creep? How can we ensure that we prevent seal creep when we're designing our packaging?
Yeah, that comes down to design. You just want to make sure that you pick an experienced design house that knows that a card should never have a point or an energy point that goes right toward the seal. A card and pouch are going to shift while inside the box. They might work together, they might work separately, but you want to make sure as much of the card, when it does impact the seal, as much of the card touches that as much as possible. That will ensure that seal creep does not happen.
So we want to prevent a dart from going through the seal. Is that basically what you're saying?
Yeah, you definitely don't want to create a dart and like in the photo where it's headed right to the seal. A lot of times, as an example, you'd want to kind of mimic the chevron shape sometimes or curve it so when it is moving again at the chevron shape, that card is touching as many points as possible.
Absolutely. What about the end or the age-old story about or question around rolled versus flat pouches?
Yeah, I hesitate talking about this too much, so I'll talk about what we do here at the Oliver Anaheim facility. But a lot of times we get 6-inch devices, but sometimes we get 6-foot devices that are extremely heavy, and we need to make concessions. A lot of times we'll roll the chevron end and the seal end of the pouch. We gently roll it. We don't fold. We don't crease. But as you see in the photo, we'll do like a toboggan-esque shape to it. And then we'll limit the depth of that box to really prevent any shifting or movement on the north-south or the depth panel of the box. That just seems to let it shift left-right a little bit, and historically it's given us a higher probability to pass testing. Again, there's a lot of our packaging or designs we do. We have light instruments as well where we leave the pouch flat, but really I bring it up because it's just a conversation that everybody should have depending on the device itself.
Yeah, so what I'm hearing is it's not necessarily a rolled versus flat. It's really very dependent on your device, your configuration, and your packaging.
Absolutely. Everybody at the end of the day, every engineer needs to pick their direction on packaging, and all we can do is talk about past projects, future projects, and then they make the call from that point.
Makes sense. So we talked a little bit about weight here. Talk to me a little bit about weight plus movement equals failure.
Yeah, so more things move inside the sterile barrier and inside the box, more damage seems to be done to that pouch. So we always try and limit as much movement inside that pouch and inside that box as possible without creating compound folds, of course. So what you're seeing here on the left.
Oh, sorry, go ahead.
Sorry. What I'm seeing on the left here is a no rail option. And so you have to make a choice. Rails stiffen the card. It prevents flexing of the card, so you can go with a no rail option, standard rail option, or we have reinforced rails, which we call the pop and lock, which are semi-assembled before shipping, and then all the operators have to do is put a little pressure to put them in place.
Yeah, when I look at these three photos, I think about the no rails would give me a little bit more comfort with not potentially not creating a breach in the sterile barrier. As I see rails, I think, oh, this might be a point on my film or my Tyvek that could have an issue. Have you seen that situation as far as no rails versus rails creating higher risk for packaging failures?
Yeah, the cool thing about cards is that it's low profile. So anytime you add a rail, you're adding height, and that means you have to widen the pouch, which could create more movement. So no rails is a great option for certain devices, because you can fit that pouch nice and tight but appropriately fitted. But then again, you got to think about the septic transfer, and is it just going to flop to the floor and cause issues there? So there's not always, sometimes you have to make concessions, or there's not a perfect answer, and you have to take in all the data and make the right call on packaging.
Great, thank you. What about the device handle and the importance of its placement on the card or in the pouch with the chevron closure?
Yeah, simple rule of thumb for us is that we always have handles and accessory pieces, lures, anything that the end user would try and grasp on opening or a septic transfer is always at the chevron side of the pouch. So that's just something that we do unless dictated to do otherwise from a engineer.
Yeah, it looks like it's a, warning, do not distribute weight with long cards. That seems counterintuitive. Can you help me understand that?
Yeah, so I totally agree. So at first, many years ago, if we had two heavy handles on devices, they went on the same card, we'd probably put them on either side of each other. But you're trying to limit movement, and when you put two heavy weights on each side of a card, and say it's a 5-6 foot card, now you're kind of causing flexing on the card. So in that testing or in the real world, card is flexing, it's creating that movement. Obviously, there's some weight because there's two heavy handles. And, we just learned through experience that to keep all the weight on one side seems to be more optimal and increase your probability of passing your testing.
Great. And yeah, so what you're seeing here on the screen, especially in the top right picture, is it's hard to show in the photo, but that's why I added this orange line that shows the edge of the card, and then that blue line shows the seal itself. So it's just showing that a chevron designed card inside of a chevron designed pouch. So Kevin, I want to show our audience this video coming up. Can you help walk us through what is happening in this video and why it's important for them to understand?
Yeah, we're trying to simulate a septic transfer. The operator is taking with one hand at first and then going two hands, really holding at the very end to show that with these pop and lock rails or reinforced rails, the cards can be really thermoform-esque and really rigid and help with this process. But also the good news is that these cards can still break down and be, a much smaller footprint than what you see and get dropped into the recycle bin.
Excellent. So we talked about, the first way to prevent packaging failure was to know the importance of knowing your product and how it's used. The second way was designing for success. And now we're going to go to the third, which is really ensuring you don't overlook the shipping configuration. So as you can imagine, there are lots of ways to design a pallet pattern, the box, the shelf carton, whatever is being used as that first mode of protection for the device and the sterile barrier. But there are a lot of different, I would say, design options there. What we're going to talk about are two things that, as I was creating this webinar with Kevin, that I was intrigued by and thought, wow, maybe a lot of people might not know this or might not consider this early on in testing. So Kevin, will you walk us through this first one, which is all about rigidity and the card in the shelf carton?
Yeah, this goes back to the slide about no rails or rails, pick your weapon depending on the need. On the left, we're just trying to illustrate what happens inside a box when a card's dropped in there without even the device. So we purposely don't have the pouch on here. We made the box clear just so you can view it better. But the one with no rails, and it's probably a 3-foot, 4-foot card, automatically or quickly conforms to the height or width panel of the box. So that's exactly what you don't want when going through testing. The device might be light enough here where you can get away with it because it takes some weight and movement to create damage in my experience. But then you can see the standard rail and the pop and lock are staying very tall and rigid, and that's kind of what you want to see inside the box during testing.
Thank you. And what about the shipping orientation and corrugation direction? Why is that important?
Yeah, so a lot of your box strength comes from the fluting or corrugation, but you have to make sure it's oriented correctly when doing the testing or when you have it on a pallet. You always want the fluting to be facing the ceiling and not side to side. If it's facing the ceiling, it's acting like a Roman column or something holding up a roof of a house, versus if it's side to side, it can quickly fold like an accordion. It's not necessarily a failure, but I've had reports back that the box doesn't perform as well when the fluting is in the wrong direction.
Yeah, so when does this usually happen, or when do people find out about this? Because I'm assuming when they come to the table, you know, when they come to talk to you about design options, they're not thinking about the corrugated box at first, or are they?
Yeah, it's usually, no, you're right. It's usually not planned. So when we ask a customer what kind of shipper configuration they want, they typically haven't thought about it. They need to go back to marketing or other people in the company to find out what direction they should be going. Should it be a 3-pack, 5-pack, 10-pack? But they're definitely not deciding which way they're going to be laying it on a pallet or so on. But yeah, usually it's just a forgotten conversation. We try and warn up front, so that's why it's on this slide today, to saying, hey, at the end of the project, it could be a week, it could be 6 months, a year of developing packaging. Don't forget to really think through how the fluting is orientated.
Yeah, absolutely. And I find what's interesting too, when it comes to the compression test, which you see here on screen, it is, it's, I put, air quotes, pass, fail test, but technically, if you fail the compression test, you're not failing your overall design verification. What that's meaning is that your box is not strong enough to withstand what it could be seeing in shipping. And therefore, it's making it weaker down the line. So while it's important to understand, your compression test and what that means, it's also important to ensure that corrugation is going to give it extra strength, because while it may not completely compress the products in that test, it is going to remove some of the strength from it performing well further down the road. Okay, so we talked about, I'm going to go through all these again and see if I have a good memory or not. We talked about the importance of knowing your design, or knowing your device and how it's used. We talked about designing for success. We've talked about the importance of not overlooking the shipping configuration. That was number 3. And number 4 is the importance of identifying your failure modes early and often. So what we're talking about here really is feasibility testing and testing to the edge of failure. So, one of the things that I love most about feasibility, and yes, I said love, is that we get to be creative, we get to fail, and we get to learn. So it's really like an engineer's playground, the reason a lot of us all went into this profession in the first place. So now I'm well aware that this is a privilege in some companies due to resources, timelines, and or awareness of packaging requirements. But given the appropriate planning and upfront communication, this is the area that can make or break your packaging project. So identifying those failure modes early and often and preparing for those in testing is really what is going to set you up for success. Kevin's talked about, they'll do a design of a card, then the engineer will take it, put it through its paces, learn something about it, and then they'll bring it back, make some tweaks, go and do it again. So there's a lot of back and forth in the design and development of packaging, just as there is with the device. And so that's why we all preach very often to get packaging involved as early as possible in the process. Of course, that does not always happen, but trying our hardest to get there, and once we get there, taking advantage of it is important. So really ensuring that you develop the appropriate test plan. So whether that's multiple rounds of testing, so maybe you're putting it through ASTM D4169 distribution cycle 13 multiple times, or maybe you're taking the drop test and increasing the height or increasing the magnitude of the vibration test, whatever makes sense per your procedures, per your process, or per your distribution environment where you think the most risk lies, it's a very important thing to understand upfront in developing your test plan. You can also have an opportunity here to test multiple configurations and materials. So if you're able to test multiple configurations and multiple materials, it's going to prevent you from, one, over-engineering, or two, under-engineering, which leads to failure. So learning, as much as you can learn in this process, the better off you will be. And then building your samples and ensuring that they're at worst case conditions is obviously important so that you can really understand that edge of failure and, you know, try to improve where that edge of failure is so that you have confidence going into your design verification. So the really important piece here is identifying those failures early and often. So I did talk a little bit about failure modes and evaluating failure modes. We have a webinar, which I believe is in you have the ability to download that, or there's a link to it in your platform here. But there's a webinar around, I think it's called Mythbusters, and it's all around failure modes. So I am a little embarrassed to admit, but I will say early on in my career, I did not know the difference between, you know, that a pinhole wasn't a pinhole, wasn't a pinhole. I thought all pinholes were just pinholes and that there was a puncture somewhere. You know, in my career, I've learned that there are, and many of you probably already knew this, so that's great, but those failure modes of whether it's a flex crack from the breach or a puncture from the breach or an abrasion from the breach, those are all different failure modes that have potentially different solutions to prevent them in your design verification. Seal creep is another one, right? There are many reasons for seal creep. There are a lot of opportunities to learn about your process, to learn about your materials, to learn about your design in this investigative area in feasibility. So highly recommend that you, as much as possible, take advantage of feasibility and really plan it into your overall timeline. Especially, you know, if you're working with a project manager that is like, wait, what are you going to do? Help them understand that a lot of projects, you know, packaging kind of being that long pole in the tent and that last check the box at the end of a project, if that fails, there's, you know, that project now has a delayed launch. So helping them understand that the risk of failure could be high if this testing isn't done up front and this learning isn't done up front. So we talked about, so that was number 4. We're going to go to number 5 here. So number 1, I wish you were a live audience so you could all shout it back to me, even though maybe you wouldn't. But number 1 is the importance of knowing your device and knowing how it's used. Number 2 was designing for success. Number 3 was the importance of not overlooking your shipping configuration. Number 4, we just talked about the importance of feasibility, identifying those failure modes early and often. And the last one, number 5, drum roll please, silent drum roll I guess, is building trust with your operators. So Kevin mentioned at the very beginning that this is his favorite. This is actually a very, very important step in understanding your design and potential watch-outs for your design. It's really all around knowing these, getting feedback from your operators. So some of these operators have years and years of experience. So many of you know how frustrating it can be to be brought into a project at the last minute, right? We've all been there. But can you imagine being the last one to know about a product that you and your team will have to build for what could be years to come, and you've never been asked for feedback, even though maybe you've been building these, you know, building products for 20 years? These operators are really a wealth of knowledge. Involve them early. Ask them for feedback. Give them a device, give them the packaging design, and ask them to assemble it without any instruction. It doesn't mean that if they can't do it, it's completely wrong. It's going to just give you more information on how to set them up for success with the procedures or whatever tools you're going to be giving them. It also allows you an opportunity to build relationships with these operators. And when you build these relationships, you're also building trust, which leads to transparency when mistakes are made. So, you know, using the ethnographic method, which is really identifying unarticulated user needs, or in this case, you know, operator needs, will help you design what is next, which is the tools that they need to set them up for success. So maybe it's a visual guide in a procedure. Maybe it's an overlay that helps them understand very clearly when something is in spec or out of spec. And my personal favorite is designing risk out of the assembly before it even gets to them. So Kevin, can you walk us through these two photos and help us understand what we're seeing here? Because, and just to give some context, when Kevin first showed me these photos, I was like, oh yeah, cool designs, great. I did not understand how these designs were very intentional in designing risk out of the assembly. So yeah, Kevin, can you walk us through that?
Absolutely. So on the left, you have a hard shell or a cover. And anytime we do covers or flaps to protect the sterile barrier from the device itself, or maybe in this case, the device we're protecting, we always like to add cutouts or features that let the assembler, after it's in the pouch, be able to see the device and make sure they can do a visual inspection that's in the right place. So that's all that's going on here, is that, yes, it's protecting the distal tip that's exposed outside the shaft of the device, probably, but yet the operator will be able to see it's there. If you cut out too big, it's a balancing act. If you cut out too big, you risk limiting the effectiveness of the cover itself. On the right, this is really cool, where the strap has two small holes. It's simple, but brilliant in my opinion. It was a good design, where there's holes on both sides of the straps, and so what it helped with when it engaged the strap, that when the holes overlapped and you could see all the way through it, it ensured that the straps were engaged properly. The manufacturing team was having issues finding ones that weren't fully assembled, and this one just made it, I guess, poka-yoke the situation.
Yeah, absolutely. These are great examples of designing risk out of the assembly, visual aids for them to see what they are doing, how they are doing, ensuring correct placement. Great examples. So thanks for sharing those with us, Kevin. So we went through all 5 ways to prevent packaging failures, and I have one bonus way. We have one bonus way to prevent packaging failures, and we've kind of hit on it throughout this entire discussion, and it's really about planning early and communicating often. I understand how hard that can be, especially the communicating piece, because there are a lot of people on a project team that are responsible for a lot of different things that can disrupt your packaging design or a successful launch of the product. But getting in early with the key players on your project team, building relationships. No joke, I have been at a happy hour with a team and something was brought up where the next day I had to go right into the office, do a design tweak, but I found out at a happy hour, even though we had had a project meeting earlier that day. So building these relationships and opening up that communication is probably the most important thing you can do to prevent packaging failures, along with the design, knowing the device, knowing how it's used, understanding the shipping configuration, building trust with your operators, and doing feasibility studies. So with that, I wanted to say thank you. On behalf of Kevin and I, we really thank you for your time, your engagement, and just your interest in this topic. What you see on the screen here is a QR code that you can scan with the camera function on your phone, and it will take you to our Pack Talk blog. Of course, I am biased because I work for Oliver, but I really do want to say that this blog has been recognized throughout our industry from people outside of Oliver, and really it has nothing to do with Oliver. It's all content that are trends and information within our industry that is just, if you're interested in what's going on and different things that are happening, different challenges people are facing, I highly recommend you take a look. You don't have to subscribe, but definitely take a look and subscribe if you so wish. But with that, thank you very much, and I'll hand it over to Daphne to facilitate questions.
Great, thank you, Jen. Jen and Kevin, thank you very much for this awesome presentation. I really appreciate it. And the videos were great too. So before we begin with our Q&A today, I did just want to direct our audience's attention to our webinar survey. It is available on the right of your presentation window. If you close this survey, you can reopen the widget by clicking the icon along the bottom of your screen. Thank you in advance for filling out the feedback form, and your participation in this really helps us serve you better. So on to our Q&A. of our portion of our event. And as a reminder, to participate in the Q&A, just type your question in the text box located to the right of the presentation window, or click the Q&A icon at the bottom of your screen. If we don't get to all submitted questions during our webinar today, we'll share them all with our speakers who can reply to you offline. So to get started, here's a question. Is there a design guide for undersizing a card to the perimeter of the pouch?
I'll let you take that one, Kevin.
Yeah, so, yeah, I mean, fit, you know, you don't want a card too small or too large in the pouch. So there is no guide, but every device has a different profile, or it could be much higher than the one next coming into the design house. So really just try and make sure there's not too much pull on the pouch or the seal. You want it in a natural lay flat position. So no, I don't have a hard and fast rule on how to size the card to the pouch, but it's more case by case. But you definitely don't want it, you want it to be interacting with the pouch during testing. You want to move with the pouch, and that seems to be the best result.
Okay, excellent. How do you handle devices with tall features that may create force concentrations in the pouch?
Well, those are the most difficult projects, I think, for any type of packaging, is when it's really tall, especially when it's just in one portion of the device. It makes it definitely a challenge because you're putting in a two-dimensional pouch, and the taller it is, the wider you have to do the pouch to get the appropriate fit. So we might come up with different features that, one, protect that tall portion, protect the film from that tall portion, and then you've got to think out the box. If it's really, really high, you might have to do something a little bit more slick, where you add a feature at the end so it can't teeter-totter or go up and down in the box itself. So again, it's all about that, limiting the movement. But to answer this appropriately, I have to see an example, unfortunately.
Okay. Okay, great. So for the card and pouch configuration, we have someone asking, does the end of the card need to match or be the same shape of the end of the pouch? For instance, a chevron equals an angled end card.
Yeah, it doesn't, it's not standard. It doesn't seem there isn't one way or the other. I like to personally do a chevron shape that touches as much of the chevron as possible. I don't include that tip at the very end because that could be that dart that Jen spoke about earlier. So no, you don't have to, and we have little reports of major issues if you don't match that chevron, but you definitely want to have a nice radius on both sides of that end to soften the blow or make sure you disperse that energy that we talked about earlier.
Okay, excellent. What's your recommendation for engineers that are limited to types of materials based on existing packaging but feel a different material would be a better option?
Yeah, Jen, you start.
I can take that one, Kevin. Yeah, so, you know, that's an interesting question, and I've dealt with this exact experience in the past. So what happens a lot of times is when you're going into a project, because you may not be early on in the project, you're constrained for time at the end, and therefore you have to look for existing materials that you already use in other products to leverage some of the testing that's already been done. If there is a good enough justification, whether it be cost savings, whether it be risk mitigation, whether it be enhanced usability from the end user, you can really create a case to help kind of share or educate your project team. And again, at the end of the day, I think our role as packaging engineers in a lot of ways is to provide the information on both sides and empower the decision maker to make the call. And when I say that, not necessarily the packaging design, but it can, when it comes to this is going to delay the project, obviously the packaging engineer is typically not the decision maker there. So, but giving the most information you can about the pluses and minuses of a new material versus an existing material will empower the decision maker to make the appropriate decision. And that's really the best you can do in those situations.
Okay, great.
Yeah, I'll add to that. Just from if that existing parameter or material is the shelf and shipper, you know, I always try and push back on that a little bit because usually the boxes are oversized and not undersized, because undersized wouldn't work well. But if that's the direction the customer wants to go after the conversation, you just want to make sure you grow the card and the pouch appropriately, because every component needs to fit with the next component to be a successful package.
Excellent. You touched on rolled pouches in the presentation. Is this acceptable depending on the design?
All I can do is go off the history of Anaheim Oliver and what we've done here, and we've had a lot of success on these bigger, heavier projects. Some of our devices we get in here are 20 plus pounds. So sometimes it's better to roll, in my opinion, and limit that movement and really dictate the narrative. If you lay it flat on a very heavy device and now you're going through testing, it's moving, and those creases, those unwanted creases that create those pinholes and things you don't want, that's going to happen randomly. I like to control the narrative a little bit, in my opinion.
Okay.
Again, the last comment on that, just make sure if you do roll that it is not a fold, it is not a crease or a pleat. That's not the direction to go.
Okay, great, thanks. You recommend to test at worst case conditions. What does that mean? Most harsh testing conditions, worst case products or tolerances, worst case packaging production parameters, or all of this?
All of the above. So it depends. I'm going to say it depends. You really have to understand the risk, right? So only you know your device and your packaging and your distribution cycles, or your distribution channels, I should say, and your company's tolerance for risk. You know all of that for your specific project, or something that you should know, at least maybe. So as you identify that, choosing your feasibility parameters in your test plan is really going to be based upon what you know about the device and the packaging and the distribution channel. So I can speak from my experience where I've done a couple of rounds of DC13 and ASTM D4169. At the end of the day, what you're trying to get the device to fail is really what you're trying to do. Now, that being said, you're going to be looking for those failure modes and understanding what could happen, and that could lead to over-engineering, but that's why you really want that time to then maybe put it through a normal cycle to see what happens. There are lots of different methodologies out there around feasibility testing, and while I definitely don't know all of them, I definitely don't know all of them. What I've done in my past has helped me design packaging that has really that has passed testing, but not what I believe to be over-engineered with the most expensive components, if that helps.
Great. Can you explain again, do not distribute weight with long cards? Does it mean try to keep weight at the same location? And how does this help?
Yeah, again, we go off our experience that we've learned, and that's what we do. And you take all the information, and at the end of the day, the engineer needs to go on their direction for that package and that design. But if you have all the weight, say you have a couple of heavy handles or items in there, we like to have it on one side of the card and not on both sides. And we're talking about really 3 foot, 4 foot, 5 foot long cards. That's when it comes into play. When you have heavy weight on both sides, north and south of the card, there seems to be more flex on that box if the box, on the packaging system, more flex on the card itself, and if that box has some height to it, it'll do that teeter-totter that you don't want. So yeah, that creating movement, we've learned this to put all the weight on one side. Within reason, there's no, again, these are just generalities, and every device that comes in here, there's a variety of things you have to make decisions based on.
Okay, thank you. So if someone's brought into a project last minute, what should their priorities be to ensure success?
I can take this one, Kevin. So a couple of things I would say. So the thing I really hate saying is that looking for existing materials, existing package designs that might exist that could work for your device. Obviously, as much as you can leverage at that point, and it really depends on how late you're brought in. So, I mean, if you're brought in, a month late and you're looking at a 2-year project, hopefully you're not too worried. If you're brought in the 11th hour, which I know happens all too often, then really you're scrambling. So your biggest strength in this situation is communicating as often as possible and helping your project manager know what you're doing and how you're doing it so that they can give you the resources and support that you need to ensure that you get that packaging designed and verified, your design verification complete as soon as possible. There are other situations where I've seen justifications happen where it's a documented exercise, and if it's rigorous enough to get through your quality team and your regulatory team, that may work as well. Now, the hope is that in those situations, you are able to evaluate and later go back to say, okay, while I met the regulations and I met the compliance and the testing necessary, were there opportunities for this design to create a competitive advantage or have some additional usability features that we just weren't able to get out with this one? And what can you learn from that so that in your next gen, or even if there's an opportunity to go back, which I know there usually isn't, creating those opportunities and that parking lot list of things that you can go back to and work on to really improve the overall brand of your product. Anything to add there, Kevin?
No, I think you said it very well. Thank you.
Okay, great. Thank you. You touched on failure modes to trays, pouches, and shippers. What are considered failures to cartons? For instance, if the sterile barrier is intact, but the carton experiences scratches and or denting, is that acceptable, or does shipping configuration need to be revisited?
I can start with that one, Kevin, and maybe you want to add on.
Sure.
I think that this is really going to depend on how what your design inputs say. So, and also marketing is going to have a say in this as well. So you're going to, sometimes it's written into your acceptance criteria that there's no exception for a gross failure. So defining what a gross failure is, right? So if these are ripped boxes or, major denting that maybe is considered a gross failure, that could be a failure and may need to be redesigned. The other thing, too, when you think about how these boxes are presented in certain situations, marketing would typically, in my experience, would need to sign off on any potential brand impact that a dirty box or a ripped box might have with the customer. And this isn't to say that that is a failure and all DV would need to be redone. But, depending on the project team and their ability or their preference for, delaying the launch or the time that you may have to potentially still meet the requirements, you may have to go back and look at some different options. But So the answer is it depends, right? It could be a failure. I've seen it be a failure in my past, and I've seen it be acceptable in the past. So it really depends on how you write your acceptance criteria and your project team's allowance for those types of failures or those types of defects.
Yeah, and I'm going to defer to Jen on pass-fail, but from aesthetics, from a packaging vantage point, design house packaging point, I want everything to look really good at the end of the testing. The box, the shipper would be the only thing that could have imperfections or some kind of showing some kind of damage or something like that. But pass-fail, that's Jen's world. But from a design standpoint, if the shelf, pouch, or card or device is having issues, we need to make some changes in the design packaging system.
Okay, excellent. Thank you both very much for sharing your expertise today, both in the presentation and in the Q&A. I really appreciate that. And I think that's about all the time we have today for questions. But we'll definitely share these questions, any questions that are remaining, with our speakers today to follow up afterward. So thank you to our sponsor, Oliver Healthcare Packaging, as well as to everyone in our audience. We appreciate your attention and your participation. Within the next 24 hours, you will receive a personalized follow-up email with details and a link to today's presentation on demand. Please feel free to invite your colleagues and peers who may not have been available to listen to our event today. This webinar is copyright 2021 by Informa. The presentation materials are owned or copyrighted by Informa Markets. The individual speakers are solely responsible for their content and their opinions. On behalf of our speakers, Kevin Fisher and Jen Goff, thank you so much for your time today, and have a great day.